Hello, Akshay. This question will said circular coil of area 2 semi-square is placed in a magnetic field of 3 Tesla perpendicularly. The coil has 10 turns and 5 ohm resistance. Now the coil is removed from magnetic field in 0.2 seconds. The value of induced charge flowing through the coil is option 1.1 millicoulomb, option B 1.9 millicoulomb, option C 1.2 millicoulomb, option D 0. So first we need to know the key concept here, which is Faraday's law. According to Faraday's law, you can say that whenever magnetic flux link with a circuit changes, an individual EMF is produced. That is, we can say magnetic flux is represented by phi, and whenever this phi changes, an EMF is induced in the circuit. Let's say the induced EMF is capital E. Okay. Now, induced EMF lasts so long as the magnetic flux continues, and lastly, we can say the magnitude of the induced EMF, that is E, is directly proportional to the rate of change in magnetic flux, that is proportional to d phi by dt. And in the next line, we can say E equals to minus d phi dt. Okay, now let's calculate the problem. We know that phi equals to that is magnetic flux equals to B vector plus A vector. B vector is the magnetic field and A is the area. So suppose angle between them is theta. So we get B into A into cos theta. Now in this case, theta equals to 0 degree. So we can say phi equals to B into A. Now this is magnetic flux for one turn, and we need to find the magnetic flux for n turns. So that will be phi equals to n into b into a for n turns. Okay. Now from key concept we can say that E equals to minus d phi by dt. तो इस इक्वेशन को हम एक नंबर मान लेते हैं। एक नंबर इक्वेशन के दोनों साइड को अगर हम डिफरेंशिएशन करें t के रेस्पेक्ट में, t means time, then we get d phi dt equals to number of turn, that is n, and area, that is a, इन दोनों का वैल्यू फिक्स रहता है, so they are constant terms into dp dt, that is change in magnetic field by change in time. तो दो नंबर इक्वेशन दैट इज E equals to माइनस डी फाई डी टी में अगर हम डी फाई डी टी के वैल्यू को पुट करें तो हमको मिलेगा E equals to n into a into dv dt, सामने एक माइनस लगेगा, राइट? Now let's go to the next slide. अब हम हर एक टर्म का वैल्यू पुट करेंगे, so we'll get equals to minus n का वैल्यू है 2 into a का वैल्यू है, you can see from this slide, 2 semi square. So 2 semi square means 2 into 10 to the power minus 4 meter square. Okay, and the change in magnetic field is 3 minus 0. Why 0? Because the coil is removed from the magnetic field, influence of the magnetic field, so the magnitude of the magnetic field becomes 0. Okay, and the change in time is 0.2 seconds. So we can write here 3 by 0.2 और 0.2 को हम लिख सकते हैं 2/10, that gives us 3 into 10/2. 2 से 10 को काट किया तो हमको 5 मिलता है. 3 into 5 means 15, and from here we can write that 10 into 10 to the power minus 4, that is 10 to the power minus 3 into 2 into 15, that is minus 30 into 10 to the power minus 3, that is minus 3 into 10 to the power minus 2 volt. Now in the next line, we can write that I equals to minus E by R. Minus into minus plus हो जाता है. So we get 3 into 10 to the power minus 2 और R का value है 5 ohm. That gives us 0.6 into 10 to the power minus 2. This much ampere, right? And we can say that I equals to Q by T. Q means induced charge, जिसका वैल्यू हमको डिटरमाइन करना है, and T is the time, that is equals to 0.6 into 10 to the power minus 2. T का वैल्यू हमको पता है 0.2 सेकेंड है, so Q equals to, we can write that 0.6 into 10 to the power minus 2 into 0.2, that is 0.12 into 10 to the power minus 2. So इधर से हम लिख सकते हैं 1.2 into 10 to the power minus 3, this much coulomb, and we know that 1 coulomb equals to 10 to the power 3 millicoulomb. So the final value becomes 1.2 into 10 to the power minus 3 into 10 to the power 3 millicoulomb, that is 1.2, this much. So this is our final answer, and among the three options we can see that option C matches our answer. Hope you have understood it well, and best of luck.